So we are moving straight to the sum of an arithmetic progression. Sum of an AP. That is, if you are given an AP like 1 plus 2 plus 3 plus 4, let's say up to 20, I want to know the sum of these values. Is there an easier formula to get the sum? Do you get it now? That is where we are going. Now look at this example we are given here. We are to find the sum of the first 100 positive integers, and then by the result we are to derive a formula or an expression for the sum of an AP. So it means if we are able to get, it will be time consuming to begin to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 till 100, right? This will consume our time. Is that not it? Okay, but let us think about it this way. Let's say we have the sum 1 plus 2 plus 3. Then I have 99 plus 100. Because the first 100 positive integers, right? So it means I'm adding from 1 to 100. Now, let's reverse the series. If I should reverse the series and I have something like this, S equals what? What will I have here? 100 plus what? 99 plus what? 98 plus 90. So now at this point, because I'm reversing, now we have what here? 2, then plus 1. So now let us assume this is equation 1, and this is equation what? 2. Take that as equation 1 and 2. So adding equation 1 and 2. Let us add up equation 1 and 2. S plus S will give us what? 2S. 1 plus 100 will give me what? 101. 2 plus 99 will also give me what? 3 plus 98 will also give me what? At the same time, 99 plus 2 will give me, and 100 plus 1 will give me. So it means that I'll be getting 101 in how many places? 100 places. So the number of terms now is how many? So we have 100 terms. So we cannot say that since there are 100 terms, that is n equals 100, right? So instead of adding 101 plus 101 plus 101 in 100 places, we can just multiply just 101, just 1, that is the first term, with 100. Is that not it? We can do it that way. So we can have 2s to be equal to 100 multiplied by what? 101. So 2s will be equal to 101, 0, 0. Right? So I can divide both sides by what? By 2. So s equals what? 5, 2 here, 0, 5, 0. Right? You can confirm that. So it means that the sum of the first 100 positive integers. So if you can take your time and pick your calculator and start pressing 1 plus 2 plus 3 plus 4, 5, like that, till you get to 100. This is what you are going to get. So what does this imply? It implies that I just need to know the number of terms, right? Then just multiply the first term with the number of terms. Divide by the coefficient of s, which is 2. Does that make sense? So now let us now try. So we have been able to answer the first part of this question. that says we should find the first 100 positive integers. Now I want to generalize this now. Let's see if we can generalize this. Now, let's say we have S, right? Let's call it the general expression for sum of an AP. The general expression. So we want to add up this. So we have this sum for equation 1. This number 1 is our what? Our first term, which is denoted with letter what? A. Are we together? 2 is our what? Second term. And second term is represented with what? A plus D. Number 3 is our what? Which is denoted with what? A plus what? And it continues like that, right? Till we get to this term, second to the last term, will be denoted with what? Last term minus D, right? Because the common difference here is what? 1. So if I do 100 minus 1, I will get what? 99. Is that not it? So last term minus common difference. Then I have 100 is our what? Last term. Very good. So let us revise the series as well. On reversing the series, so this is our equation 1, and we have the sum. 100 is our what? Last term, right? So it means every time I'm having it, I'm bringing them back in. So I will start from the last term, like that. So what will I have here? 99 is my what? Second to last term. L minus D. 98 is what? L minus 2D. So it will continue like that. L minus 3D till we get to, something simpler. Now, 2 is my what? A plus D. Because I'm reversing it. And 1, just like what we did here, is our what? A. That's our equation 2, right? So we can now add equation 1 and 2 now. Adding up equation 1 and 2. S plus S will give me what? 2S. A plus N will give me what? A plus N, right? Now, A plus D plus L minus D will still give me what? A plus N. Because you have A plus D plus L minus D. So if you open this bracket, you have A plus D plus L plus times minus D minus D. So this one will take care of this, right? So you see end up having A plus L. So I have A plus L. A plus 2D plus L minus 2D. We still give you what? A plus L. The same way. So you have A plus L. Like that. L minus D plus A plus D is still what? A plus L. Then A plus L plus A will still give me A plus L. I think I can write that here. A plus L. Right? Now, how many A plus L am I supposed to get? 100. And we said that 100 is our what? N. That's the number of terms. Very good. So, in that case, we have 2s equals 2s equals Like what we did here. We said the number of terms multiplied by the first term, right? N into what I have here? A plus N. Is that not it? So to get the sum, we divide both sides by what? By 2. So we divide both sides by 2. So I have 2s over 2. So we equal to n over 2 into a plus n. So this takes care of this. Then s equals n over 2 into a plus n. And this is the first expression for the sum of an AP. Right? Now, recall that you are given that the last term, which is our nth term, is also given as what? A plus n minus 1d. So I can substitute for L. Do you get it now? I can replace this L here. So I can have S equals n over 2 into A plus our n is now A plus n minus 1d. So let me use a square bracket to differentiate this. Then S will be equal to n over 2 into A plus A is what? 2A plus n minus 1. So we have equation 2. Now, what does this imply? What does this imply? It implies that if I am given an AP that has the last term, whose last term is known, something like this. Do you get it now? For known last term, N. If I know my N, then I use the first expression easily. Do you get it now? Once I have my N, my A, so I can calculate the sum. I will use sum is what? N over 2 into A plus N. First term plus last term. For last term not given, L not given. If I don't know my last term, then I come for this one. Do you get it now? You can see we already replaced last term with this expression A plus N minus 1D. Then I will use sum of an AP to be N over 2 into 2A plus N minus 1D. So I think that is that. So that also satisfies the other question that says we should derive a general expression. So take note of this and this. So this is D. Okay, I think that makes sense. Yes? Yes. Yeah. Yeah. All right. Before now, we already said if you are given an AP, let's say an AP of this nature, 1 plus 2 plus 3 plus 4. The first term here, this is our first term. We denote it with letter what? A. Now, what is the difference between this and this? They have a common difference of 1. What's the difference between this and this? A common difference of what? 2. Now, this is it. Our target is the first term. We are more concerned with the first term and the common difference. From there, we can get other terms. Look at it. My first term, T1, is A, right? The second term, T2. What is different? You know this, we are dealing with sum here. What is different between this one and this one? 1. So let's call that common difference, D. So T2 is now A plus D. Because first term is 1. Common difference is also 1. So 1 plus 1 will give us 2. Now let's go to the third one, T3. Like I said, we are concerned with the first term and the common difference. I don't have problem with this. The first term is A. What is the difference between this and this? 2. So I have to multiply by that common difference. Do you get it now? So A plus what? 2D. Because common difference term is 1. So 1 times 2 will give me that. Do you get it now? So 2 plus 1 will give me 3. Now, the same thing applies here till the last term. Then we can now add up and reverse it. I think that makes sense. Alright, thank you.